Hi everyone. Today we are going to understand about the different structures of the models of atoms which help us to understand what exactly was the structure of an atom. Various scientists put forth theories. We will today understand Rutherford's model. Okay, so to understand Rutherford's model, I'm going to share a screen with you. Now, Rutherford, because before are embedded into the positive mass of the atom. But was it exactly true? Well, he decided to actually do an experiment for that. So since he wanted to know how electrons were arranged in an atom, he designed an experiment where fast-moving alpha particles were made to fall on a thin gold foil. Now, gold, you know, is highly malleable, so you can make it into thin sheets. And this gold foil was just about 1,000 atoms thick. Then, what is alpha particle? Now, if you take helium atom, helium has got two positive charges, so it also has two electrons. Now, if you remove two electrons, then helium would have a +2 charge. So these are the alpha particles, doubly charged helium ions. It has become an ion because it has got charged. And the mass, well, the mass remains the same. It has a mass of 4U. U is the unit of the atomic mass, unified mass. Okay. The fast moving alpha particles have a considerable amount of energy. So it was expected that the alpha particles, when they strike the gold foil, they would be deflected by subatomic particles in the gold atoms. What exactly happened? We have to see. Now, to understand where these have struck, the thin gold foil had a circular fluorescent zinc sulfide screen around it. Something like this. Okay, you have the source of the alpha particle, which will bombard alpha particle on the thin gold foil, and it was surrounded by a zinc sulfide screen. So whenever alpha particles struck the screen, a tiny flash of light was produced at that point. Okay, so that helped Rutherford to observe where exactly the alpha particles were going, and was it being hindered, was it being stopped, or it went unhindered and struck it, the screen. He made some observations. Whenever we do an experiment, we always observe what we are seeing. And we record those observations and then we come to conclusions. So what were these observations? Well, let us see. Now, it was observed that the alpha particles, most of them, they passed through the gold foil undeflected. They just went ahead and struck the screen. Secondly, he observed a small fraction of the alpha particles was deflected by small angles. And then he also observed that a very few, just approximately 1 in 20,000 of these alpha particles, they bounced back as if they were rebounded, striking against something which has the same charge. Remember, alpha particles were charged. They were positively charged species. So they were reflected by nearly 180 degrees. Something like this, as you can see at the bottom of the screen. Most of the particles went ahead. Nothing was there to stop them. Some of them, they deflected by small angles, whereas 1 in 20,000 just went back 180 degrees. Okay, so based on these observations, Rutherford concluded certain things. So what were the conclusions drawn by Rutherford? Well, most of the space in an atom is empty. Why? Because he found that most of the alpha particles pass through the foil without any deflection. A few positively charged alpha particles were deflected. And the deflection must be due to the enormous repulsive force, showing that the positive charge of the atom is not spread throughout the atom as Thomson had produced. He had thought, he had presumed that it was, uniformly spread. But it's not so. The positive charge had to be concentrated in a very, very small volume that repelled and deflected the positively charged alpha particles. So he calculated and he found that the volume occupied by the nucleus is negligibly small compared to the total volume of an atom. The radius of the atom, he calculated, was about 10 raised to minus 10 meters. That's a very small number, while that of the nucleus was 10 to the power minus 15 meters, even smaller. Okay, so what was his proposition of the model of an atom? Well, you can see a diagram on the top. Okay, well, this is something which reminds you of the solar system. So Rutherford proposed his model of an atom similar to the solar system. One is the positive charge and most of the mass of the atom was densely concentrated in an extremely small region, and this small portion, he called it nucleus. Okay, Rutherford called this small portion nucleus. The nucleus was surrounded by electrons that move around the nucleus with very high speed in circular paths called orbits. And in this way, actually, our Rutherford's model resembles the solar system, in which nucleus plays the role of the sun and electrons are revolving just like the planets around the sun. Then the electrons don't just move away, they don't leave the atom and go. They are held by something. Well, the nucleus and the electrons, they are held together by electrostatic forces of attraction. Remember, nucleus is positively charged and the electrons are negatively charged. So, did this model have any drawbacks at all, or was it accepted? There were some drawbacks. What were those drawbacks? Let us see that. See, any particle which is revolving in a circular orbit undergoes acceleration. That's classical physics. During acceleration, a charged particle would radiate energy. As you can see here, it looks as if a lot of energy is getting radiated. Now, we are talking about electrons. Electron is a charged particle, so that would radiate energy when it is revolving fast. And so, a revolving electron would lose energy and finally it would lose energy and fall into the nucleus. And that would be the end of the atom. But atom exists. That means this model had certain drawbacks. Were the further models also similar to this? How did the other scientists build up upon this Rutherford's model? We will see in our next module. Thanks for watching.